Okay, question 5 is one of our QWC questions, our quality of our written communication. So, what we're going to do is we're going to use our acronym, our HIAD, which means we need to highlight, illustrate, recognize the part of mathematics we're using, explain, and make a decision at the end. And so what we're going to do is first of all do that highlighting phase at the start. So we've run through the question. It says a community hall has a large number of rectangular tables and a large number of chairs. The table can seat up to 3 people along each of the longer sides and 1 person at each end. So I've highlighted those two as important bits of information. Then says a street party has been organised using the tables and chairs. Tables are joined and placed in a long straight line. Tables meet edge to edge to form the line. Now we're asked what is the least number of tables needed to seat 164 people, and we're reminded that we must show all our workings and explain how we get to our answer. So the first thing I'm going to do after I've highlighted is illustrate what is going on. So first of all I'm going to say that for one table we would just have one table with 3 people along the longer sides, which we talked about, and 1 at either end. For two tables, we've got our 2 tables lined up next to each other, so we've still got 3 people either side, which is a total of 6 people, and that's the same for my second table. But this time I've just got 1 at that end and 1 at that end, so no one in this middle bit by here of our tables where they join. So I might want to do a third one just to check. So for 3 tables, and if I line them up together, 1, 2 and 3, I've still got my 6 people per table, my 3 on either side, and the last 2 people again are at the end. So what have I noticed when I've been answering my question then? So what I've got is for every table there are 6 people with always only 2 at the far end. So that allows us to do our calculation. So we can say for 164 people, 164 take away 2 at the ends equals 162. And so now we know that there's always 6 people left over then for every table. So to find the tables, to find the number of tables, we divide by the 6 because there were 6 people on each table. So just running out a little bit of room by here. But if we did our calculation just underneath, 162 divided by the 6, 6 goes into 1 no times, 6 goes into 16 twice with 4 left over, and 6 goes into 42. 5 6 is a 36, 6 is a 36, 7 6 is a 42. So our final answer, just might have to write underneath here for now. So for 164 people, there are at least 27 tables. And there's our answer for our 6 marks. Now for part B, we are told there are n people sitting around a straight line of tables and there are no empty seats. we need to write an expression in terms of n. So that means we need to write something with, well, something using algebra with n in it for the least number of tables needed to seat these people. Now, above, we used 164 minus the 2 people at the end, and then we divided that by 6 because there are always 6 people, 3 on either side per table. And that gave us our 27 tables in the end. Now, let's say, for example, I had, 14 people. If I took away the 2 at the end and divided by 6, so 14 take away 2 is 12, divided by 6, that would tell me I had 2 tables. So I know that this is kind of the formula, well, it is the formula that I've been using each time to work out the number of tables. So I'm always taking away 2 and then dividing by 6. So if I had n people sitting, so that means any number of people sitting around the tables, to work out my answer, I would do exactly the same thing. I would take away 2 and divide by 6. So that is my expression, it's my algebra, in terms of n. So n minus 2 over 6, and that tells me the least number of tables needed to seat the people. And that's all we need for the 3 marks.